ഉണ്ണികൃഷ്ണൻ സാർ ജോയിൻ ചെയ്തിട്ടുണ്ട്. പ്രിൻസിപ്പല് പിന്നെ സലീം സാറ്, സയ്യിദ് സാറൊക്കെ ജോയിൻ ചെയ്തിട്ടുണ്ട് അല്ലേ? എന്തെങ്കിലും ലെഫ്റ്റ് ആയതാവും, ഇപ്പൊ വരുമായിരിക്കും. സയ്യിദ് സാറിനെ കാണുന്നില്ല.
ഹലോ, സ്റ്റാർട്ട് ചെയ്യാം മാഡം. സ്റ്റാർട്ട് ചെയ്യാം. അതെ
ടീച്ചർ, ഞാനും ഉണ്ട്. സലീം സാറും കയറിയിട്ടുണ്ട്.
സൂപ്പി സാറൊക്കെ കയറിയിട്ടുണ്ടല്ലോ അല്ലേ?
കയറാൻ പറയാം.
തുടങ്ങാലോ അല്ലേ സാർ?
തുടങ്ങാലോ. തുടങ്ങാം. സാറ് ഉണ്ണീകൃഷ്ണൻ സാർ വന്നിട്ടുണ്ടെങ്കിൽ തുടങ്ങാം.
ഉണ്ണീഷ് സാർ എത്തിയിട്ടുണ്ട്. ഉണ്ണീഷ് സാറെ കേൾക്കാലോ അല്ലേ? ഉണ്ണീഷ് സാർ ഉണ്ണികൃഷ്ണൻ സാർ ഓക്കെ ആണോ? ഹലോ സാർ. സാറിന് ചെറിയൊരു ടെക്നിക്കൽ പ്രശ്നം പറഞ്ഞായിരുന്നു, ശരിയായിട്ടുണ്ട്. ഓക്കെ സാർ. ഉണ്ണീകൃഷ്ണൻ സാർ തുടങ്ങാൻ പറഞ്ഞൊരു മെസ്സേജ് അയച്ചിട്ടുണ്ട്. അപ്പൊ നമുക്ക് തുടങ്ങാം.
സ്റ്റാർട്ട് ചെയ്യാം മാഡം, സ്റ്റാർട്ട് ചെയ്യാം നമുക്ക്.
Respected Principal Sir, Dr. Mohammadi Sir, our Chairman, Sri Salim Guruvambalam, Chief Guest of the Day, Dr. Unnikrishnan Sir, NIT Calicut, Academic Director, Dr. Sahil Sir, Vice Principal, Professor Supi Sir, my friends, faculties from other colleges, research scholars, and students. Good morning to all. കേൾക്കുന്നുണ്ടല്ലോ അല്ലേ? കേൾക്കുന്നുണ്ടല്ലോ അല്ലേ?
കേൾക്കുന്നുണ്ട് മാഡം, കേൾക്കുന്നുണ്ട്.
Okay, thank you. So the Department of Chemistry is extremely glad to host this 5-day program, faculty enrichment program on Polymers for Environment. The year 1920 is very special in the history of chemistry, especially in the history of polymer chemistry. The first paper, the name of the paper was Uber polymerization. The meaning was on polymerization. That paper was published by Schrödinger in 1920, and this paper is considered as the foundation of polymer chemistry. And since then, these polymer materials have a tremendous impact on our society. These polymer materials have changed our life. Was published to a great extent by Schrödinger, and he was the first person, and this was the first person to refer the polymer materials as macromolecules, which is very commonly used nowadays. And Schrödinger received Nobel Prize in chemistry in 1953 for his works in this area. And 2020 is the century year of this publication. So when we look back, we will be amazed to see the extent of changes these materials have made in our life in every area over these 100 years. We cannot live even a day without polymers or plastics or rubbers. That is the situation now. So that is the impact of polymers on our life. So when we expand the use of polymers, the next problem is how to deal with the polymer waste. That's the next problem. Over a few years after starting the usage of polymers, we are facing that problem seriously now, because we cannot do away with plastics or polymers, but at the same time, we are facing this serious problem of solid waste created by the use of plastics, rubbers, or generally polymers. So that is the significance of this program, the Polymers for Environment. How to make these plastics, rubbers, or polymers eco-friendly so that we can conveniently use them, because we cannot do away with the plastics or polymers. So that is the significance of this 5-day program. And I hope after these 5 days, we will have a better exposure into more environment-friendly polymers, or how to use polymers eco-friendly, or how to make polymers eco-friendly. So such ideas will be given by our eminent resource persons. Today, we are having our principal, Dr. Mohammad Ali sir, to preside over the function. Being a man of chemistry for many years, he has always shown consideration, special consideration to our department, and he has encouraged all programs of this type. So without his support and encouragement, this program would not have been materialized. So on behalf of the Department of Chemistry, I welcome our principal, Dr. Mohammad Ali sir, to this program.
Thank you, madam.
Thank you, sir. Now we have our chief guest, Dr. Unnikrishnan sir, Professor NIT Calicut, here to inaugurate the program and also to give the to handle the first technical session as a resource person. He is a person of great experience in academics, industries, research, teaching, and administration also. So we are lucky to have such an experienced person here to inaugurate the function and also to handle the technical session today. He has supervised 30 PhD papers, and he has authorized 264 technical articles, 12 projects funded by various agencies, including British Council, and he has patent for four patents. And Dr. Unnikrishnan is a recipient of Professor Shankarlal Memorial National Seminar Award from IIT Kharagpur and the Best Performer Award from NIT Calicut. He was a visiting research at Department of Chemistry, University of Leeds in UK. And he is very much interested in social outreach programs also. So he was the founder secretary of Calicut chapter for Society for Polymer Science, the faculty in charge of Social Engineering Forum. This is a forum in NIT Calicut. It's a platform for connecting NIT Calicut with society or with public. So he is in charge of that forum also. So today we are having an eminent resource person here for us to take the first technical session also. So on behalf of the whole academic community who have assembled here, I welcome you, sir, to this program. I welcome Dr. Unnikrishnan, sir, to this program. And I'm happy that our Sri Salim Kuruvambalam, sir, our chairman, college governing body, is attending this program. And we all appreciated, or we are very well know the efforts he taken under his leadership for the past few years for improving the quality of education in Malappuram district. This has become a model for other areas in Kerala also.
Thank you, madam.
So,
thank you.
Thank you, sir. So I welcome Salim Guruvambalan, sir, to this program. And we have our other management members who had promised to participate. So I welcome them, our secretary and correspondent, Janab CP Hamza Haji, our president, K.S. Tangal, our general secretary, Mustafil Faisi, and treasurer Manu Haji. I welcome all of them to this program in their absence. And our academic director, Dr. Sahir sir, is here. He is also very encouraging for this type of programs. He always give all support. And I, on behalf of the Department of Chemistry, I welcome Dr. Sahir sir to this program. And Professor Supi sir, our vice principal, is here. He is also very much interested in organizing this type of programs. I welcome Professor Supi sir to this program. And Mr. Rafiq, IQAC coordinator, Mr. Dr. Pilla sir, our staff secretary and HOD Hindi, is also attending this program. To felicitate this program, I extend a hearty welcome to them also. And I extend a very hearty welcome to all the faculties, research scholars, PG students, and the students of my own department and all my colleagues to this program. Once again, I welcome all of you to this program, and I invite our principal, Dr. Mohammad Ali sir, for the function.
Thank you, Madam Shantakumari, Madam, Professor, and Head of the Department of Postgraduate Department of Chemistry. Esteemed chief guest of the program, Dr. G. Unnikrishnan, sir, Professor and Head of the Department of Chemistry, NIT Calicut, our beloved Chairman of the College Governing Council, Janab Salim Kuruvambalam, sir, Director of the College, Dr. Safir, Vice Principal, Professor Supi, sir, faculty members from various institutions and from Majlis, students and other research scholars. Good morning to you all. At the very outset, let me congratulate the Postgraduate Department of Chemistry, Head of the Department, Professor Shantakumari Madam, and all the team and the students for organizing the 5-day program to commemorate the 100th anniversary of the paper published by Hermann Staudinger, who is considered as the father of polymer chemistry. As Madam told, the importance of this seminar, which is a webinar turned into webinar because of the very special COVID-19 pandemic situation. We, all these years, last 100 years, we have seen various polymers serving the mankind in various forms. Not only on the tires or the vehicles we ride every day, but what are things you see and use right from the brush of a toothbrush, plastic one, and the writing pen, everything is made up of polymers, plastics. And we chemists have classified these polymers into various classes, and the students of chemistry are also aware about the classification. And an important classification now to focus is the biodegradable and non-biodegradable polymers. As you know, the polymer plastic, its menace due to the pollution is now a talk. So even in the campuses, we have the Green Campus Initiative, many, where the different kind of solid waste management is there, where you can see, the students can see there is dustbin kept, waste bins kept for biodegradable and non-biodegradable plastics. So because of the pollution, because these plastics which are not biodegradable can persist in the soil for years and years, decades and decades, we can say, it is affecting the soil fertility and many other toxicity into the soil, because not only the pure component which is coming into the plastic, like see ethylene polymer, polyethylene, but there are many other components added into it, like the plasticizers, many other. So these kind of reagents added all are, we can see, toxic. So because of this harmful effects, now scientists started developing the biodegradable polymers, in which nature itself has given us a large number of polymers. And by mimicking those polymers, we can even convert them into the actual polymers into, or we can by mixing with the natural polymers, to some extent, we can degrade them. So a lot of research are going into the biodegradable polymers, and also in the material world. If you see the material world, we can see a lot of changes happening these days, not only in the metals and the alloys of it, but in the plastics and various other things also. Because various properties also should possessed by the polymers, including the inflammable nature, and it's how they can withstand the pressure, various pressure, suppose it is used in the potable water, drinking water. So polymers should possess unique properties for their unique uses. And these years, we know that because of the technological advancement, various kind of polymers are developed by the scientists to suit our various uses. Even for the stitches of the surgery, we have the switches used which are biodegradable, and a lot of activities are going even in space technology. Previously, space technology means the rockets used to launch the satellites of the kind of a 4,000 kg, but now it is reduced into we can see nano satellites of 1 kilogram or 2 kg, but with same performance or better performance we can expect from all these materials. So a lot of activities are going on these current years because of the advancement of the polymer chemistry. With these few words, let me stop my talk because we are eagerly waiting our beloved Unnikrishnan sir, who is a pioneer in the field of polymers, and he has visited Valancheri MES KVM College when I was there as principal, I remember. And one or two occasions also I met him from NIT Calicut. So he's a very interesting personality to open this kind of a program, and a very seasoned scientist. I have to talk about Unnikrishnan sir, and I thank Chandakumari madam for inviting him so that our faculties and the students can interact with him and get ideas and to know about a person like Unnikrishnan sir, who is always involved in the research and teaching of chemistry. With these few words, I now invite our Honorable Chief Guest, Unnikrishnan sir, to please come, sir, for inauguration. Thank you, sir.
Hello, thank you, Mohammed Ali sir, for the kind words. Hello, am I audible?
Yes, sir.
Yeah. I'm extremely thankful to the management of Majlis Arts and Science College, Pramannur, Valancheri. It's a great experience. I visited Valancheri College multiple times. I have had wonderful experiences. Our own team member, Dr. Rajesh, is also there. So, Majlis College also I visited earlier. Professor Shantakumari is there. So, I'm extremely happy to get associated with the Majlis Arts and Science College. This college has a very bright legacy. It was started in 1995. Now it completed, last year it completed the Silver Jubilee. Earlier, now the department, now the college is having 16 UG programs and 7 PG programs. Under the able guidance of all the management people, I have great respect to Janab CP Hamza Haji, Secretary of Majlis Education Complex, Janab Salim Kurumbalam, Janab KS Tangal, Janab Musaful Faisi, Janab Manu Haji, all these people, Professor Shantamari told me that all these people put in their best efforts to build up a very, very dynamic, vibrant academic ambience in the institute. They 24 hours they work for the organization, and people like Dr. Muhammad Ali, Dr. Shantakumari, Dr. Shafiq, and many people are behind the success of this institute. The Department of Chemistry of the college is also very strong. They are the people, I understand that the department people are very dedicated. That's why they have decided to organize this program, because this year is very special for people working in the field of macromolecular science, because 100 years back, Hermann Staudinger, a very vibrant, very dynamic German organic chemist, proposed that the molecules we see are not simple molecules alone. There are molecules which are associations of small molecules, and which make our life wonderful and very productive. So I will be touching upon the fundamentals of macromolecular science and the new aspects of molecular science in my lecture. But prior to that, I have to do an official duty of inaugurating this great event. I really appreciate the department people who took all the wonderful program, because all are troubled by the corona issues, but irrespective of all the painful experiences, the people here, they took all the pain to organize such a wonderful program. I am extremely happy to see that the program is being done with great care. The organizers have done, because the selection of the content of the theme of the program, they have done it very carefully. Dr. Drishya Shashidharan, Mr. Hari Mohan, both of them deserve big words of appreciation. I appreciate all the people behind the growth of Majlis Arts and Science College. In the changing world, there is tough competition amongst colleges under one university and amongst the universities in states. And in India, we have a ranking system now coming, and organization of such programs will definitely enhance the rating of Majlis Arts and Science College. So you may be having great pains to organize a program, because ensuring participation, etc., is also a tough job now during these Corona days. But still, the management and the faculty members, department people, they all were successful to organize this program elegantly. I appreciate all the people behind this program once again. And with the consent of all the people, I declare this wonderful program opened. Thank you very much. Jai Hind. Hello.
Hello.
Ma'am, could you hear me clearly?
Yes, sir. Yes. Now it is audible, sir.
Yeah. Now, ma'am, it's you may kindly invite the next speaker.
Okay, sir. Now, I think our secretary and correspondent has not joined yet. So, I invite our chairman, college governing body, Janab Salim Kuruvambalam, to say a few words. Salim, sir.
Okay. Okay, start ചെയ്യാലോ അല്ലേ?
Okay, can say.
Okay, sir. Okay, ma'am.
Yeah, okay.
കെമിസ്ട്രി ഡിപ്പാർട്ട്മെന്റിന്റെ നേതൃത്വത്തിൽ നടക്കാനിരിക്കുന്ന ഈ പഞ്ചദിന പ്രോഗ്രാമിന്റെ ഉദ്ഘാടന ചടങ്ങിലെ അധ്യക്ഷൻ കോളേജ് പ്രിൻസിപ്പൽ ഡോക്ടർ മുഹമ്മദ് അലി സാർ, ഇന്നത്തെ നമ്മുടെ ചീഫ് ഗസ്റ്റ് ഡോക്ടർ ഉണ്ണികൃഷ്ണൻ NIT കാലിക്കറ്റ്, പ്രൊഫസർ ശാന്തകുമാരി അടക്കമുള്ള ഡിപ്പാർട്ട്മെന്റിലെ എൻ്റെ അധ്യാപക സുഹൃത്തുക്കളെ, വൈസ് പ്രിൻസിപ്പൽ, ഡയറക്ടർ, ഈ വെബിനാറിൽ പങ്കെടുത്തുകൊണ്ടിരിക്കുന്ന മറ്റു വിശിഷ്ടാതിഥികൾ, പ്രിയ സഹോദരന്മാർ, ഈ കോവിഡ് മഹാമാരിക്കിടയിലും ഇത്തരം ഒരു വെബിനാർ സംഘടിപ്പിക്കാൻ മുന്നോട്ട് വന്ന കോളേജിലെ കെമിസ്ട്രി ഡിപ്പാർട്ട്മെന്റിന് നേതൃത്വം നൽകുന്ന പ്രൊഫസർ ശാന്തകുമാരി, അതുപോലെ അവരുടെ സഹപ്രവർത്തകർക്കും മാനേജ്മെന്റ് കമ്മിറ്റിയുടെ പ്രത്യേക അഭിനന്ദനം അർപ്പിക്കാൻ ഞാൻ ഈ സമയം ഉപയോഗിക്കുകയാണ്. 25 വർഷം പിന്നിടുന്ന മജ്ലിസ് ആർട്സ് ആൻഡ് സയൻസ് കോളേജ് ഇനിയും ഒരുപാട് ദൂരങ്ങൾ കടന്നു പോകേണ്ടതായിട്ടുണ്ട്, ഒരുപാട് വഴികൾ കടന്നു പോകേണ്ടതായിട്ടുണ്ട്. ഓരോ കാലികമായ പാഠ്യപ്രവർത്തനങ്ങളിൽ, അതുപോലെ വിവിധ ഡിപ്പാർട്ട്മെന്റുകളുടെ ഡെവലപ്മെന്റിന് ആവശ്യമായിട്ടുള്ള ദൈനംദിന പരിപാടികൾ നമുക്ക് സംഘടിപ്പിക്കേണ്ടതായിട്ടുണ്ട് എന്നാണ് നാം മനസ്സിലാക്കുന്നത്. വിവിധ ഡിപ്പാർട്ട്മെന്റുകൾക്ക് മാതൃകയാകുന്ന തരത്തിലുള്ള, ആവേശം നൽകുന്ന തരത്തിലുള്ള പ്രവർത്തനമാണ് കെമിസ്ട്രി ഡിപ്പാർട്ട്മെന്റ് നേതൃത്വത്തിൽ ഇപ്പോൾ നടന്നു വരുന്ന ഈ പഞ്ചദിന ഡെവലപ്മെന്റ് സെമിനാർ പ്രോഗ്രാം എന്ന് നാം വിലയിരുത്തുകയാണ്. തീർച്ചയായും നിങ്ങൾ കാണിച്ച ആത്മാർത്ഥമായ ഈ ശ്രമത്തിന് മാനേജ്മെന്റ് കമ്മിറ്റിയുടെ ഭാഗത്തു നിന്നുള്ള എല്ലാ പിന്തുണയും ഉണ്ടാകും. നമ്മുടെ ഉദ്ഘാടകൻ മജ്ലിസ് മാനേജ്മെന്റിനെ കുറിച്ച് പറഞ്ഞ എല്ലാ നല്ല വാക്കുകൾക്കും നന്ദി രേഖപ്പെടുത്തുകയാണ്. മജ്ലിസ് മാനേജ്മെന്റിന്റെ വേറെ പ്രത്യേകമായ ഒരു താല്പര്യങ്ങളും ഇല്ലാതെയാണ് സമൂഹത്തിന് വേണ്ടി വിദ്യാഭ്യാസ മേഖലയിൽ എന്ത് ചെയ്യാൻ സാധിക്കും, എന്തൊക്കെ സംഭാവനകൾ നമുക്ക് അർപ്പിക്കാൻ സാധിക്കും, അത്തരത്തിലുള്ള പ്രവർത്തനങ്ങളാണ് മജ്ലിസ് മാനേജ്മെന്റ് കമ്മിറ്റിയുടെ ഭാഗത്തു നിന്ന് എല്ലാ കാലഘട്ടത്തിലും ഉണ്ടായിട്ടുള്ളത്. തീർച്ചയായും അതിന് കരുത്ത് പകരുന്ന തരത്തിലാണ് നിങ്ങളുടെ ഈ പഞ്ചദിന പ്രോഗ്രാം എന്ന് നോക്കിക്കാണുന്നതിൽ ഏറെ സന്തോഷവും ചാരിതാർത്ഥ്യവുമുണ്ട്. അതുകൊണ്ട് ഈ സെമിനാർ വഴി നിങ്ങൾ ഓരോരുത്തർക്കും, നമ്മുടെ ഡിപ്പാർട്ട്മെന്റിൽ വർക്ക് ചെയ്യുന്ന എല്ലാവർക്കും അതിന്റെ ഗുണഫലം ലഭിക്കുമാറാകട്ടെ എന്ന് പ്രത്യാശിക്കുന്നു. അതുവഴി നമ്മുടെ വിദ്യാർത്ഥികൾക്കും സമൂഹത്തിനും അതിന്റെ ഗുണകരമായ എല്ലാ വശങ്ങളും ഉൾക്കൊള്ളാൻ കഴിയട്ടെ എന്ന് ആത്മാർത്ഥമായി ആഗ്രഹിക്കുകയും പ്രത്യാശിക്കുകയും ചെയ്തുകൊണ്ട് ഈ സെമിനാറിന് പിന്നിൽ പ്രവർത്തിച്ച എല്ലാവരെയും ഒരിക്കൽ കൂടെ അഭിനന്ദിച്ചുകൊണ്ട് പരിപാടിക്ക് എല്ലാവിധ അഭിവാദ്യങ്ങളും അർപ്പിച്ചു നിർത്തുന്നു. നന്ദി. ജയ് ഹിന്ദ്.
Thank you, sir. Thank you for your kind words.
Okay.
Now I invite our Vice Principal, Professor Soupy, sir.
Hello.
Hello.
Good morning. Good morning, everybody.
കേൾക്കുന്നുണ്ട് sir.
Okay. Thank you, sir. Madam. Respected Principal, Dr. Mohammad sir, Chief Guest of and RP of today, Dr. G. Unnikrishnan sir, Professor NIT Calicut, HOD of Chemistry Department, Professor Sandakumari Madam, and our governing body chairman, Salim Kurambanu Sahib, Pilla sir, അതുപോലെ നമ്മുടെ മാനേജ്മെന്റിന്റെ our management committee members, Dr. B. Pirla sir, Rafiq sir, our director Dr. Safi sir, and other dignitaries, and also the beloved students and members of the faculty. Today we are conducting, the Department of Chemistry is conducting a 5-day faculty enrichment program, and they are selected topic, a polymers for environment. Actually, this is a very important topic because we are all dealt with the human society, or human beings are consuming the polymers or the plastics. It is unavoidable, the use of polymers or plastics in our life, day-to-day life. So the problems or the issues or the pollution, the condition, the use and the use of the benefits and the damages which is causing to the human beings, all these should be understood or should be aware. We need the awareness of all these things to the society, and to the educated people, and also the educated students should give the details or the information regarding this item to the common people. Those who are not aware of this, the difficulties or the problems or the uses of these polymers or plastics. Anyway, this is a very important subject, and the resource person who is dealing the topic is a well-known personality in the field of this topic. Polymers for environment is a very useful, and it is very common matter, common subject to be discussed in the society, especially in the educated people, to be aware and to give the details to the common people. I am not elaborating my speech. Within this 5-day program, this faculty enrichment program, we hope this will be very useful and beneficial to our students, and also the Department of Chemistry, and all the teachers and students, those who are attended this program. I congratulate the Department of Chemistry, and also especially the department HOD, Professor Sandakumari Madam. She is very active, even though she is a little aged personality. She is very active, and she is very energetic and enthusiastic to conduct all these programs. day before yesterday, only before 2 days only, the department also conducted an alumni meet. It was very successful. Actually, the global alumni were actively participated in this program. So I congratulate the department HOD and also the dedicated members of the department also. We hope in future also the departments and also other departments of chemistry as well as the other departments of our college will conduct more programs for the sake and for the benefit of our students. Thank you all. Thank you once again. Thank you very much and goodbye and Jai Hind.
Thank you, sir. Thank you for your kind words. Next, I invite our academic director, Dr. Safir Atikaden, for felicitating the function.
Thank you, madam. Am I audible?
Yes, sir.
Esteemed guest of the day, Dr. G. Unnikrishnan sir, professor from NIT Calicut, Honorable Chairman of our college, Janab Salim Kurumbalam, respected Principal Dr. Muhammad Ali sir, beloved Vice Principal Supi sir, most respected and most beloved Head of the Department of Chemistry, Professor Shantakumari madam, our IQAC Coordinator Rafiq sir, Staff Secretary Dr. Pilla sir, my dear colleagues, Department of Chemistry of Majlis Arts and Science College and from other neighboring institutes, and dear students. It's a matter of great pleasure that the Department of Chemistry is organizing a 5 days faculty enrichment program for the faculty members of chemistry under the Calicut University and for the PG students. And I congratulate Professor Shantakumari madam and her young energy team of faculty members for organizing this kind of program, and they deserve special kind of appreciation for selecting this kind of eminent personalities like Dr. G. Unnikrishnan from biodata. Understood that he is such a kind of an eminent personality, has produced more than 3 PhDs and a number of case field chemistry. So by inviting this kind of professors to interact with our faculty members, they are getting such a kind of great opportunity. So and giving this kind of opportunity to faculty members and students, not only from for faculty members of our college. And I think, or I understand that faculty members of other institutions are also participating in this. So I congratulate the department for organizing this and wish all the best for this 5 days faculty enrichment program. Thank you, Jai Hind.
Thank you, Sahir sir. Next, I invite our IQAC coordinator, Mr. Rafiq. Mr. Rafiq. I think Rafiq is not in the group. Pilla sir, our staff secretary and HOD Hindi. I think they are having classes, online classes they are taking. They had mentioned. So next I invite Mohammad Shenu, second year MSc Chemistry student, for the formal vote of thanks.
Good afternoon, everyone. I hope I'm audible to you.
Yes,
Thank you, ma'am. Respected dignitaries, our beloved chief guest, Dr. G. Unnikrishnan, sir, and my dear friends and teachers, it gives me an immense pleasure to deliver the vote of thanks to all the dignitaries who are assembled here. Yes, after the discovery of the polymers 100 years back, there we can see a revolutionary change or a tremendous influence of this material in our society. And when we consider the positive and negative side of the plastics and its associated material, it is true that nowadays its negative side is more projected. So now we are in a state of confusion that whether this polymer is a boon or curse to the humanity. So hence we have to develop material which are very convenient for us to use and also at the same time eco-friendly. That is the significance of this 5-day webinar series, Polymers for Environment. Okay. Then first and foremost, I take this golden opportunity to thank the respected chief guest, Dr. G. Unnikrishnan, sir, professor of NIT Calicut, who despite his busy schedule has found the time to grace our occasion. And I also express my heartfelt thanks to Dr. P. Muhammad Ali, sir, principal of Majlis Arts and Science College, who honored this function with his thoughts and views. Then I owe special gratitude to the Professor Shantakumari ma'am, head of the Department of Chemistry, Majlis Arts and Science College, and the backbone and the strength of our organizing committee also. And I'm also very grateful to Janab C.P. Hamza Haji, Secretary of Majlis Educational Complex, in his absence, and also Salim Karuvambulam, the Chairman of College Governing Body, for his valuable contribution. And I also extend my gratitude to all the well-wishers of the event. And at last, but not least, I sincerely thank all the audience who listened to me. You are the strength of this program. Once again, I thank one and all present here. Thank you. Have a nice day.
Thank you. Well done.
Thank you, sir.
Thank you, Shanu. Thank you very much.
Thank you, ma'am.
Now, we are at the end of this inaugural session. And the first technical session we have to begin. And I invite Professor Abdul Jalil sir of our department to chair the function. Jalil sir.
മാഡം ഞാനൊന്ന് പൊക്കോട്ടെ?
ആയിക്കോട്ടെ സാർ, വളരെ താങ്ക്സ് സാർ.
ഓക്കെ ഓക്കെ, താങ്ക് യു.
ആയിക്കോട്ടെ സാർ, ഞങ്ങള് ഇനി സെഷൻസ് സ്റ്റാർട്ട് ചെയ്യാൻ. ഓക്കെ. ജലീൽ സർ.
ഹലോ.
കേൾക്കുന്നുണ്ട് സാർ, കേൾക്കുന്നുണ്ട്.
Am I audible? Oh.
Yes sir, കേൾക്കുന്നുണ്ട്, പറഞ്ഞോളൂ.
Esteemed resource person of the day, Professor G. Unnikrishnan sir, our beloved principal, Dr. Muhammad Ali sir, Vice Principal, Sophie sir, Academic Director, Safir sir, Gopika Madhu, our Lake Hari Mohan, faculty from different colleges, students and research scholars. Today is the first our 5-day faculty the enrichment program. Polymer and Polymer for Environment. We know that for macromolecules are large molecules, so thousands of covalently connected atoms. These are formed by many monomers linking with forming a polymer. As we heard in the intro session, in 1920, a publication by Hermann Schrödinger, an organic chemist, reached the scientific community. He published an article titled on describing the first time the concept of molecules consisting of a large number of repeating units. This paper and Schrödinger's subsequent papers on the topic can be considered as the foundation of the field of macromolecular chemistry. And Hermann Schrödinger's pioneering theories on the polymer structures of fibers and plastics, and his later research on biological macromolecules formed the basis for countless modern developments in the field of material science and biosciences, and supported the rapid growth of plastic industry. This new concept, referred to as the macromolecule by Schrödinger in 1922, both synthetic and natural polymers, and was the key to the wide range of modern polymeric materials and innovative applications. Today, the molecular architectures of synthetic polymers and biopolymers are tailored with a high precision to meet the demands of technology. The products of polymer chemistry are diverse, from food packaging, textile fibers, auto parts, and toys to membrane for desalination, carriers used in controlled drug release, and biopolymers for tissue engineering. Schrödinger's revolutionary publication are celebrating its 100th anniversary in 2020, as mentioned earlier. Since 1920, much has happened, and polymer chemistry and physics has evolved into an important research field. Furthermore, polymers have also made progress economically and have become indispensable in many areas of our daily lives. The anniversary of 100 years of polymer chemistry offers the opportunity to look back to the past, to view the present, and look ahead of future. In this context, we are conducting this 5-day faculty enrichment program in Polymer for Environment. With these few words, I am concluding my introductory remarks, and I invite our respected resource person, Dr. G. Unnikrishnan, to present today's topic, Charm of Macromolecules and New Trends. Dr. Unnikrishnan.
Thank you, Dr. Abdul Jalil. Wonderful introduction. You have given an introduction to what I am going to say. So it's a great introduction. In fact, I could not mention a big thanks to Professor Sufi sir also. So I could not do that. I do that now because I missed his name earlier. I'm thankful to Professor Sufi sir also for inviting me to this program. I'm showing the slides to you. If you can see, please tell me. If you cannot see, please tell me. Are the slides visible?
Visible, sir.
Oh, thank you very much. I once again express my sincere thanks to the management, faculty, principal, and all people of Majlis Arts and Science College, and all people who are behind the arrangement of this program. I will be quickly going through the history of macromolecules and the new trends, including conducting polymers and Grubbs catalysis through metathesis, ring opening, polymerization, how people develop now polymers across the globe. Prior to that, I have to say a word to the young faculty members who are attending this program. I have had wonderful experiences through faculty development programs because through these faculty development programs, we develop a networking. Hundreds of young, bright minds got connected to NIT Calicut through a faculty development programs. Many of them came forward to do their PhD programs at NIT Calicut. And later we have tens of experiences where they themselves have later became research guides and they have started their own research groups at their institution. And in that way, they have contributed to the growth of their college, the university, and to the total academic system of the state and the country. In that way, faculty development programs tell you that you have wonderful chances, you have great responsibilities to your state and the country. And once you give value addition to yourself in your profession, you are doing a value addition to the state and the country and to the world as a whole. So in that way, I appreciate all of you for taking time to attend this 5-day program and to give value additions to you. I'm sure that after this program, you will be having more effective deliveries, lecture deliveries in the classrooms, more effective interactions with the students, because I have seen other speakers are, I have seen Dr. George, Dr. Ramesh, I have seen Dr. Your own faculty at Balajiri, my own student, Dr. Rajesh is there. The other people are also there. So they are extremely good in their field. So the connectivity will definitely help you in your profession. And, actually, the macromolecular science we learn now, all the conveniences we enjoy now are being derived from material science. All the branches are being derived of engineering are being supplemented or modified or implemented by the best efforts of research from the field of material science. When we look to material science, we see that these three materials, number one, metals, number two, ceramics, number two, polymers, actually they build up all the, you look in the room, you are sitting in a room, you look around, you will be seeing all the materials made either out of metal, ceramics, or polymers. And that's the chart. We are primarily now focusing on the third category called polymers, which are big molecules. Actually, you can compare, a scientist will always compare the beauty of a flower, with the macromolecular assemblies. We can see large number of petals making beautiful flowers. Nature has arranged them wonderfully. The job of a scientist is to do that. Make molecules which others have not made. That's our job. We live to make molecules which others have not made. We live to characterize molecules which others have not done. We live to find out new applications for molecules. That makes your life more meaningful. The moment we say of big molecules, the first question coming in our mind is how big they are. Are they big like an ant? Are they big like an orange? Are they big like an apple? So we'll be having dimensional. We have to develop dimensional concepts in our mind. So develop dimensional concepts. I tell you, Dalton in 1804 said that all matter is made out of atoms. I'm showing you a cartoon, a picture. An atom is shown like this. This is an atom. If you look at an atom, the dimension is approximately 10 raised to minus 10 meter. We call it as 1 angstrom unit. 1 angstrom unit. If I couple that angstrom unit with a second angstrom unit or a second atom, I will be getting a dimension of 2 angstrom unit. 1 plus 1, that makes 2. 2 angstrom. So those 2 angstrom unit dimension is a little bit bigger than the conventional small angstrom unit. So this structure is drawn like. So this is called a small molecule. When atoms combine together, this is called a molecule. Dimension could be approximately 2 angstrom unit plus or minus. Now, if I link this 2 angstrom unit with many of the 6 angstrom units or not, or some other things. So this is a 2 angstrom unit dimension molecule. This is a 2-dimension angstrom unit dimension. I get a 4 angstrom unit connectivity. I call it as a 2 connection. I call it as a dimer. Mer means part, 2 parts dimer. 2 parts combined together to develop a structure. Obviously, its dimension will be 4 angstrom unit plus or minus. Similarly, if I connect 3 molecules, the process I am doing is called trimerization. 3. 3 parts are doing. Obviously, the dimension will be 6 angstrom unit. Later, I can do tetramerization, connecting 4 molecules together. The dimension obviously will be 8 angstrom unit. And as I keep on doing that job, I get a small 2 angstrom unit molecule upon connection n times, multiple times, I will be getting a bigger structure. That's known as a big molecule. This is known as a small molecule. It's called a macro mega molecule. That's actually a polymer. This dimension is 2 angstrom unit approximately, but this angstrom, upon their combining multiple times, this dimension may go to 100 nanometer, 1000 nanometer, and it may go even up to micro dimensions. Nature has a wonderful strategy to do that. Nature makes small molecules compared to bigger molecules. In our body, what more nature does is nature combines large number of small sugar molecules to develop macromolecules called carbohydrates, bigger molecule, polysaccharides. So carbohydrate formulation is a macromolecular science. In our body, that essential, all the chemical reactions in the body are being executed by proteins. And proteins, they generate strength also to the body. And all the proteins are macromolecules. They are being derived from small molecules called amino acids, amino NH2, acid COOH. So if you couple amino acid groups together, you make a macromolecule. Similarly, look in the structure of DNA and RNA, ribonucleic acid. Nucleic acids are polymers. Nucleic acids are derived from small molecules, nucleic acids, combined together to develop RNA as well as DNA, which are present in our as chromosomes in our nucleus of the cell. Similarly, the lipids we have, they are also being derived from lipids. So lipids, fat, bigger fatty molecules, meaning the carbohydrates which are present in our body, the proteins present in our body, the nucleic acid present in our body, RNA, DNA present in chromosomes, and the lipids which give the body again strength and many other properties. They are macromolecules, meaning the existence of small molecules is extremely important. Equally important is the existence of bigger molecules called macromolecules. So This is a macromolecule having a dimension of some nanometer. This cannot be detected by our eye because our eye cannot see matter below 0.05, 0.25 millimeter like that. No, so when you give the assemblies of such structures, so definitely 1 nanometer will not be seen by your eye. But when you make the assemblies of typically if this is 50 nanometer, 50 plus 50 plus 50 plus 50 plus 50 plus 50, that gives you a dimension which can be detected by your eyes. So that gives us a visible product. So this is what a scientist does in the laboratory. So what he does is he plays with small molecules, organic molecules as well as inorganic molecules. Sometimes organic molecules duly supported by inorganic molecules. They develop big molecules, small. So connecting minds and connecting molecules, that's our job. The job of a faculty is to connect the minds of students. And the job of him or her in the laboratory is to connect small molecules. So connecting small molecules, getting connected with the students, that is the primary job of a teacher, which obviously you all are doing pretty well. That is why you all attend this program. So you get big molecules. And those who teach polymer science in the classroom, they know pretty well that polymers, we see them as plastics, rubbers, fibers, and adhesives. When small molecules are connected to make big molecules, those big molecules having a specific property called plasticity. When those big molecules are having a property called plasticity, workability, you can mold them in the desired shape. You might have seen in an aircraft or in a car, hundreds of plastic materials you've seen. Those materials having plasticity are known as plastic materials. But in another category of material, look in the tire of a car, that's having not only plasticity, but the very known property called elasticity or reversibility. You try to deform a polymer chain, deform a macromolecule chain, just like a rubber band, it tries to come back to the original position. That is not elastic nature, rubbery nature. Some of the macromolecules appear as fibers, nylon fiber, adamant fiber, cotton fiber. Large number of fibers are there, and some of them as adhesives. Typically, heraldite we use at home is an adhesive we derive from epoxy resin with a combined with a hardener. So you have this structure plastic, this structure rubber, you have fibers, cotton, and adhesives, typically physical. And a scientist carefully looks into the dimensions, the small dimensions. Actually, they are of these macromolecules are the dimension of still 500 nanometer. You can have sometimes 25 nanometer like that. So I'm consolidating what we are saying is, if all the plastic carry bags we have at home, if you subject it to a high resolution microscope, you can see that the carry bags are made out of small type of molecules which are known as macromolecules. This is a macromolecule, this is a macromolecule, this is a macromolecule, this is a macromolecule. The complete, you do not see individually, but their collection is seen as a plastic carry bag. And if you take one molecule and resolve it, you will be seeing small molecules getting connected. So small molecules which are in angstrom units, they grow like threads which form this. And finally, will be then assembled. They make such assembled for visible form. This is what macromolecules are nano or microns which we may not see directly. We will not see directly because the human eye detects.
Excuse me, sir.
Yes, please.
Excuse me, sir.
Yes, I'm listening to you, sir. You cannot hear me? Hello?
We are facing some breaking in the audio.
Is it
Audio
clear now,
is
sir?
not 100%.
Is it clear now?
We are experiencing some break.
Is it clear now, sir? Hello? Is it clear now, sir?
Hello.
Yes,
Hello.
now it
Okay,
is
okay.
clear. Now it is clear.
Now it is clear.
Here, but no, you sir, ma'am, do you advise me to repeat some points I said, or it's okay?
It's okay, sir. You may continue.
Okay, okay. Now it is clear, ma'am.
Yes. The audio was not clear, sir.
Oh, audio was right from the beginning. It was not clear.
Yes. I know it is audible, but it's a little bit feeble, sir.
Now it's okay.
Now it's better.
Yeah. Okay. Hello.
Hello.
Is it clear now? Hello, ma'am. Is it clear
Hello.
now, ma'am? Hello.
Once again, it is stable.
Now it is feeble, sir. The other one was
No,
okay.
ma'am.
This one.
Now is it okay?
It is better, sir. Now it is better.
Okay. Okay, ma'am. I'm trying once again. Hello, is it okay, ma'am?
Now it is okay, sir.
Hello, ma'am. Shall I proceed?
Okay. Now it is okay.
Yeah. I'm proceeding. So I will quickly go through some interesting inventions which happened. Hello, is it clear?
Yes, sir. Now it's clear.
I'm quickly going through some interesting inventions which happened even before Schrodinger. Actually, Schrodinger was not the man who saw polymers first time. So I quickly go through the history, some 3, 4, 5 points before that. The first point is this happened in 1830, not in 1830. This man was a great man from France. His name is Henry Brackenot. Henry Brackenot, along with his partner Christian, they were the first people to develop the material called cellulose derivative, celluloid or cellulose acetate. Cellulose acetate, actually not the cellulose which we obtain from coir fiber, banana fiber, etc. And these materials, actually celluloid is this man is also known for finding out chitin and pectin, which are plenty present in many of the natural fibers, typically coir. And this material, celluloid, is nothing but nitrocellulose. Cellulose after nitration gives nitrocellulose. Nitrocellulose combined with camphor gives us a material called celluloid. You all may be knowing what is the celluloid. Celluloid is nothing but which contributed significantly to the development of motion picture films. All the films we have seen before the digital era, we were seeing films through pictures through films. And these films were being assembled by the invention happened in 1830, and subsequently in 1890, the actual celluloid company production started in 1890. You may be knowing that the first movie came in 1895. So all the entertainment now we have belongs to the polymer field, and people started enjoying a lot of films because they could record, they could view. Movies started. That happened in 19. This is the first factory which started producing the. You might have seen different types of films coming in boxes earlier. Now it is the digital format. The term polymer was introduced by a great man, Berzelius, in 1833. The first invention I said you was in 1830. This Berzelius is a man who is a member of the BBDL team. BBDL team means this is B stands for Boyle. This B stands for our Berzelius. This D stands for our Dalton. And this L stands for Lavoisier, who is known as the father of chemistry. So Berzelius was enjoying such a big status amongst the scientists during 1800s. He was the man who first named polymer. Remember, this happened at least 80 years before that the actual molecular architecture was proposed by our great man Hermann Schrödinger. That happened in 1920. And 1840 was a wonderful time for, again, this was the first time he said that cellulose was the first plastic product. This is a plastic product. We said that plastics, rubbish, fibers, and that. This was first a plastic product. Then elastomeric rubbers were known to people, but now we know that rubbers are being modified by sulfur. The technique is known as vulcanization. That was introduced by a man 1814 by Friedrich and Hayward. So their introduction, they noted that, but still vulcanization was not introduced. That happened only, but these two people suggested that if you try to do some chemistry on rubber was known that time. Much earlier, rubber was known, but it was not recognized as a polymer. It was started recognized as a polymer only after the work of Schrödinger. Meaning, what I'm highlighting is cellulose is a polymer, but not recognized at that time. This is rubber is a polymer, but not recognized as a time. But systematic recognition and the characterization, etc., which we do now in the laboratory, happened only after Schrödinger. 1844 was a great year for us. You might have seen Goodyear tires. 1844, this first man called Goodyear took a patent on the process called vulcanization. In parallel, UK also goes that credit. Thomas Hancock, his name also might have heard of it. Hancock registered a patent in UK during that time. So we started the history from 1830. Now we reach 1830, 1844 to the period of 1830 of Berzelius. 1884 was the first time then fibers appeared. We said of plastics, we said of rubbers. Fibers were introduced by Hilary D. Chardonnay. This man, in fact, derived, you can see in the picture, fiber in the polymer in the fibrous form. So what he did was, cellulose was dissolved in cupramonium hydroxide. So you know that cellulose is a very crystalline material. It is very difficult to dissolve. It will not dissolve in water. It will not dissolve in many of the organic solvents. But cupramonium hydroxide it has very strong polar structures. So cupramonium hydroxide is a good solvent we use in the laboratory to make cellulose dissolved. And upon treating that solution, cellulose dissolved in cupramonium hydroxide, then when treated with sulfuric acid, slowly started forming beautiful fibers. And these fibers were the first fibers reported in history. That happened in 1884. All this now we use, the dresses are being made out of fibers. The technology was growing very, very fast. And in 1900s, when a great man, this man with Mugan, this is known as the Bakeland, Dr. Bakeland, who was the first man to introduce, this is known as the plastic industry. The term plastic was even before polymer, it was utilizing, but the later only this structure, etc. Now FTIR, NMR, XRD, DSE, all these characterizations happened only after Schrödinger's work. Meaning, there were many, many great people in history who contributed to the growth of polymer science. So I wish that all of you would be also a part of this long chain. We belong to that category. We have that feeling. And this is a great man, Hermann Schrödinger, who is his contribution. He was not the man to invent any polymer. Many people have the confusion that Schrödinger was the first man to propose a polymer. That is not right there. Schrödinger contribution, he was only a good organic chemist. Schrödinger contribution was, he took the existing polymers and identified that they are not like conventional molecules having 2-dimension, 3-dimension size, but they are assemblies. Till then, people could find that polymers, but they believed that they are like colloids. Now we define colloids as particles having a dimension of 10 to 2000 angstrom units. Schrödinger also suggested that, so before Schrödinger, people believed that molecules were there, big molecules were there, but they were not called as big molecules or macromolecules or polymers. They were considered as colloidal associations. And this great finding, Schrödinger said that nature has small molecules as well as big molecules. Nature has, hello, can you hear me? Hello.
It's audible. It's audible.
Are you hearing me? Hello, are you,
Yes, sir.
hello, are you hearing
Yes,
me?
sir. Yes, sir.
Yeah. Shall
But
I shall I continue?
Still, it's a little bit feeble, sir. The voice is not that much clear. But when you ask the
Still, ma'am,
questions, it
you
is,
can you okay, you can recognize sound, you know.
yes, it's okay, sir.
Yeah. Ma'am, how many minutes more I can take?
You may complete it, sir. You may complete your session.
I may take 15-20 minutes more. Is it okay?
Okay, sir. That's okay, sir.
Okay.
That's okay.
Thank you, ma'am. So Staudinger got a Nobel Prize in 1953 for his great work. And these people are great people. No, Hermann Mark. He was the first man to conduct X-ray on polymeric systems. And he was the man actually who proposed that there are long chains of repeating molecular units. You know the importance of this man. You might have heard of a great scientist called Linus Pauling. He did fundamental Pauling structure, Pauling theory, etc. X-ray diffraction from Mark. So such a huge, big personality. And those who are working in the field of polymer science know that the Journal of Polymer Science is a very popular journal having very good impact factor, started in 1940s by this man. So he dark young brain at that time into the field of polymer science. And you might have seen this man's picture. His name is called Carothers. He's working in a big company called DuPont, and that Carothers was the first man to develop a polymer in the laboratory. Till then, Scottish were Mark, previous were Mark, all these people worked with the natural polymers. Carothers said that the simple organic chemical reactions we do, whatever we do in the simple chemical reactionization, addition, etc., these reactions were being done by organic chemists in the laboratory. He extended that. If you carefully extend the conditions of the reactions, you can make big molecules. As you make small molecules, you can make small. Carothers also written in gold letters in the history of polymer science. And before he entered the modern era, Watson and Crick, by that time, 1962, proposed that not only in the synthetic laboratory, but also in our nature is the biggest macromolecular scientist. He said that body is having some structure called nucleic acids, which are actually polymeric substances, and they call them as biopolymers. And it was a great time. Natta and Ziegler, they made that polymerization can be well controlled from the outside of the reactor or a test tube. You can make polymers as you wish. This is Natta, this is Ziegler. And you can control the reaction stereo specificity of the reaction using some specific catalysts called Ziegler-Natta catalysts. So they were heterogeneous catalysts, sometimes homogeneous catalysts. And this is a great man. My professor had a connection with his laboratory, and he's a wonderful theoretical polymer chemist who proposed a concept of network densities, building features, etc. Again, a Nobel Prize. And you might have heard when a rubber ball is cooled, it will become rigid. That is because of the property called phase transition. And the phase transitions were proposed in Pierre Gilles in 1991, another breakthrough. And this is what I said in 2000, when this century started, there was a wonderful invention by Alan Jehiker and Shirakawa that till then polymers were being employed as insulators. When you cover polymer, when you cover material when you cover a conducting material with a polymer, you will not get shocked. Current will not enter your body. So they were keeping as passive roles in conductivity. Insulation was the primary job. And these three people said that, see, people, we are polymer scientists. we can make polymers conducting exactly equal to the conductivity of metal. So they have started a new field of people now call the electronics, complete electronics is being, more of the electronics we do is now a bigger contribution from the scientists, these three scientists. They contributed to the field of molecular electronics. They were also awarded Nobel Prize. And in 2002, people were, these are some of the potential areas where now young people like you work now. We have biological macromolecules like DNA. We try to mimic such molecules. We try to make such molecules in the laboratory. So we can identify structures, characterize. There are beautiful characterization protocols existing now to evaluate the structure of bigger molecules. And this is one of the recent inventions, 3 people on dice to receive a Nobel Prize. These, you might have seen this man, his name is called Grubbs, Grubbs. Grubbs, Chauvin, and Schoch. They received Nobel Prize in 2005 because of the job. Those
Sir, not audible now.
I think the mic is off. Hello, sir.
ജലീൽ സർ മെസ്സേജ് അയക്കണം സാറിന്, സാർ കേൾക്കുന്നുണ്ടാവില്ല. സർ
Hello, sir. Hello, sir. Unnikrishnan, sir.
മെസ്സേജ് സാറ് കണ്ടിട്ടില്ല തോന്നുന്നു, വോയിസ് കേൾക്കുന്നില്ല.
Microphone.
ഹലോ ഹലോ സർ, ഉണ്ണികൃഷ്ണൻ സർ. ഹലോ ഹലോ സർ.
സാറിന്റെ മൈക്രോഫോൺ.
ഹലോ ഹലോ സർ.
ഹലോ, സാർ. സാർ, ഉണ്ണികൃഷ്ണൻ സാർ.
ഫോണിലൊന്ന് കോണ്ടാക്ട് ചെയ്യാം.
താങ്കൾ വിളിക്കുന്ന നമ്പർ ഇപ്പോൾ ഇതാണ്. ദയവായി അല്പസമയത്തിന് ശേഷം ശ്രമിക്കുക. The number you have dialed is currently busy. Please try later. आपके द्वारा डायल किया गया नंबर अभी व्यस्त
പക്ഷെ സ്ലൈഡ് മാറുന്നുണ്ടല്ലോ.
ഹലോ, ഞാൻ ഫോണിൽ കോണ്ടാക്ട് ചെയ്തിരുന്നു. സാറിന് എന്തോ അവിടെ ഓഡിയോ പ്രശ്നമുള്ളത് കൊണ്ടാണ്. സാർ ഒന്നും കൂടെ ശരിയാക്കുന്നുണ്ട്. ഇവിടെ മുതൽക്കാണ് സാർ കേൾക്കാതെ ആയത്.
ഹലോ
ഹലോ,
കേൾക്കാമോ മാം? കേൾക്കാമോ? ഇപ്പൊ കേൾക്കാമോ?
ഇപ്പൊ കേൾക്കുന്നുണ്ട് സാർ.
മാഡം ഈ സ്ലൈഡ് വെച്ചല്ലേ കട്ടായി പോയത്?
അതെ അതെ, ഈ സ്ലൈഡിന്റെ അവിടെ നിന്ന് അങ്ങോട്ട് കേൾക്കുന്നില്ലായിരുന്നു.
ഞാൻ പറയാം, സോറി ഫോർ ദാറ്റ്. ഐ എം എക്സ്ട്രീംലി സോറി ഫോർ ദാറ്റ്.
ഇറ്റ്സ് ഓൾ റൈറ്റ്.
So this man, this is the slide you are seeing now is the Grubbs and his team. Grubbs and 3 members, Shok and Chauvin. They are receiving Nobel Prize in 2005 for the great work called olefin metathesis. So this is being catalyzed by a catalyst called Grubbs catalyst. For developing this first generation catalyst, they got Nobel Prize. So olefin metathesis, I will explain you in a couple of minutes. It's the exchange of double bonds. So upon you doing that, you will be developing new types of monomers which can be polymerized to develop new types of polymers. So the technology we have developed over in synthesis is we can do addition reaction, we can make condensation reaction. The mechanism could be free radical or ionic, and this is a great work by this is the introduction of material. Those who teach organic chemistry, that we know palladium catalyst cross-coupling reactions, Hick reaction, negative reaction, Suzuki reaction, Soda-Gashler reaction, Stille coupling, or thousands of hundreds of polymers were developed by palladium catalyst cross-coupling reactions. So again, a Nobel Prize for 2010, and by doing just like Grubbs catalyst reaction, we can develop new types of monomers by doing this palladium catalyst cross-coupling reaction, and those can be subsequently polymerized to develop beautiful molecules which others have not seen. So you can see a pentagon with sulfur, a thiophene structure that is being polymerized by using palladium or a nickel catalyst. So this is a pentagon with sulfur. Only one is a small monomer, but this is pentagon linked multiple times. This is a polymer. This kind of many young people like you, they develop monomers into new types of polymers, and you might have seen wonderful work appearing in macromolecules, Journal of American Business Society, etc. This is what I said you of Grubbs olefin metathesis. Again, in new work. So you can see that this is an olefin, carbon, double bond, 4 valencies are being satisfied. This is another monomer, carbon, double bond. Another groups or ligands are attached. So, but this carbon is having R dash, this carbon is having R only. This is red and this is blue. But you can see the change what happened. This C gets R and R, but this C is being replaced by C dash. Actually, this bond dissociation, it breaks from half from here, half from here. The 2 halves join to this molecule, the other 2 halves join to make this molecule. So we get a fresh monomer which can subsequently be two monomers which can subsequently be polymerized to develop very beautiful molecules. And subsequently, this is a very new area in polymer science called ring opening metathesis polymerization called Romp is being modulated and moderated and propagated by Grubbs catalyst. Again, we are connecting our polymer science with the recent novel work. You can develop new types of molecules from strained rings. This is a strained ring. You might have known it's a strained ring. Upon ring opening, it will automatically undergo opening if you give a small triggering. So such a triggering will develop you bigger structures, macrostructures. So these are some typical examples. And the macromolecules have once you do that, for what purpose I am developing these materials? I am developing these materials to contribute to my country and to the world in the field of electronics. You can see that all the light weighting awards now in the market, many of the electronic circuits, the systems in the market are being derived from polymeric substances. These electronics and electrical people heavily depend upon us to make new molecules. Similarly, clinical doctors heavily depend upon us. Typically, Sri Radhinathal Institute of Medical Science, you might have heard, they're developing blood bags from PVC. And completely, most of the part of our body can now be replaced by polymers. So we have eye being supported by contact lenses. We can have a heart assisting system called cardiac pacemaker, cochlear assisting our ear, which is known as a cochlear implant. Many tubes being inserted into our body for different purposes called catheters. And many of the drug delivery systems we employ. A large number of students have been graduated from our group based on drug delivery systems. Hydrocephalic shunt to remove excess fluid from the brain. So you have a large number of polymers, and these materials are wonderful. That's why the charm of polymers are increasing day by day. And a large number of biodegradable polymers are people now look for. Earlier, we were using polymers being derived from monomers, which are derived from petroleum industry. But now people look for polymers which can be developed from the nature, so that after their utilization, they can undergo degradation and go back to the environment. I will stop so the essence is that the man you are seeing here is called Sherlock Holmes. You might have seen Sherlock Holmes was a great chemist. He was a private detective. Sherlock Holmes always used to say that for you to become successful in life, either in your personal life or in your professional life, see things through a lens. Always make a difference by observations. Make differences by observation. People see but don't observe. That was his famous statement. People see but don't observe. You right from the morning, nature is giving large number of possibilities in front of you in the form of molecules which others have not seen. In the flower, in your garden, in your backyard, you have seen large number of plants which contain molecules which can be isolated, modified. So this is the job of a scientist. A scientist is in one sense a Sherlock Holmes. So the curiosity is the driving concept. Once you have this curiosity lens in one, the other is not appreciated, but the right-hand side equipment called lens. Once you have that lens, you define yourself as a Sherlock Holmes to see the world in a different way. So I guarantee you, this technique was told by our professors earlier. Try to see world in a different way. And over the years, we try to do that. And that gives us totally different experiences. And based on such experiences at NIT Calicut, those who have visited NIT might have seen the picture, this is the entrance of NIT Calicut. So our group has developed some new polymeric materials based on poly. I will quickly go through it for 5 minutes and then I will wind up. We have identified a material called polylactic acid. Now a thesis is now getting completed based on polylactic acid. Polylactic acid is a polymer which can be derived from sugarcane, corn, sugar beet, wheat, potato, etc. So once you develop that polymer, it's a very bioplastic material. The charm is that it can be used to make our domestic appliances from cups, bottles, etc. to professional, high grade products for medical applications. And this can be subjected to a large number of processes, even including 3D printing. We might have heard of the process called 3D printing, three-dimensional printing, where a polymer, actually a product in 3D printing is being derived from a polymer only. So they are doing printing, the ink there, actually 3D printer is an extruder. 3D printer is an extruder, but extruder moves in 3 dimensions. Conventional extruder is static, but 3D printer extrude is moving in 360-degree angle. And then the ink comes out. Ink is actually a polymer. So that comes out, it develops into a product called 3D printed product. So polylactic acid can be subjected to 3D printing. So it's a darling of industrials now. If you look to the publications level, many young dynamic people in US, in UK, in Australia, in South Africa, they all work on this material now. 10,000 publications, more than 10,000 publications appear. Even now, this is a statistics up to 2020. Large number of publications appear in the span during this period. So the statistics for 2014, 2020. So they are being employed for a large number of publications. So our desk, this is the work from our desk. This is my student Darima. So it appeared we got 3 publications together. This is one of wonderful work. This is an employment of polylactic acid to encapsulate silver nanoparticles to enhance the efficiency. Silver particles are excellent catalyst, but their catalytic efficiency can be significantly altered by integrating silver nanoparticles with polylactic acid. So the story we have done is we have integrated polylactic acid with silver nanoparticles to enhance the nitro reduction to amino group. So this is the job we have done. Quickly, I have go through the slides. I shall leave the slides to Professor Shantakumari. You can have the slides later, because in a 5-minute, 7-minute presentation, you cannot understand the technology. I understand. So, but you can do that. So this is polylactic acid. This is silver nitrate. This is glucose, which is a reducing agent. We have integrated them 3. So heroes and heroines. Polylactic acid is the hero. Heroine is silver nitrate. Another heroine is glucose. The story happens in presence of sodium hydroxide. So we will see polylactic acid getting trapped with the silver, neutral silver. Glucose getting oxidized to gluconic acid, and NaNO3 is 2 other byproducts. So we have developed, we can change, when we fabricate such beautiful films, we can change the content of silver based on the content of polylactic acid. So we have 0 lactic acid, means it's only polylactic acid alone. We have then made another composition which is having, we have made another composition which is having 10 weight percentage of polylactic silver nitrate, 20, 30, etc. And we have characterized them using UV visual spectroscopy. This UV visual spectroscopy is this is glucose alone. This is silver alone. This is silver alone in dichloromethane medium. So you can see that there are multiple peaks. Multiple peaks indicate that different types of particles are there. Different types of particles, dimensions exist. But you can see in presence of lactic acid, you get only 1 absorption peak, which is an indication that PLA is a very good agent to generate homogenization within the system. We have peak 10 means it contains 10% of silver. This contains 20% silver, 30% silver. But out of this, the 20 silver is the ideal one we have identified because of multiple reasons. The 30 system is 10 is weak, 30 is weak, but 20 has been found to be extremely good in many systems. And based on that, we have developed, this was appreciated by many people. This is those who are working on membranes. This is an ideal strategy. It's called breath figure technique for developing porous systems. What you do is you take polylactic acid and silver particles dissolved or dispersed in a solvent like chloromethane, And obviously, when you get it exposed, the solvent will try to vaporize. But doing that process, if you do it in a humid chamber where a lot of humidity is there is a magic happening. So if you do it polylactic, solid will go out. But if you do it with the water around, humid environment, there's a magic happening. As the solvent goes out, water will start condensing onto the membrane. You will see water getting condensed onto the membrane. Then, after slowly you heating out, water will get evaporated at 100 degrees centigrade, obviously. And if you slowly evaporate the solid ice heating, you do not have to give it to 100 degrees centigrade. Slowly you can raise the temperature. You can see that water will and the solvent, complete evaporation of water as well as solid happens, and you will be getting beautiful membranes. And this is a very interesting strategy to develop porous systems. You can characterize them using X-ray. You can characterize, you see that these are the beautiful pores. So what do you think of it? Using these pores, you can utilize these pores for drug delivery. You can encapsulate different types of drugs in the system, and you can release different types of system, different types of drugs into that. You can analyze it with scanning electron microscopy, transmission electron microscopy. You can find out the particle dimensions. The particles were found to be 8.7. This is the 8.7 nanometers. So this is a part of nanotechnology. DAX is the technique by which we use elemental analysis, and thermal characterization can be done with this TSE result, this mechanical property examination, and subsequently we have employed it for catalytic activity. Those who are very familiar with the UV visible spectrum, you can see that without our catalyst means silver particle trapped in PLA, this is the primary peak you obtain. Nothing is here. But if you do with this is only the ion belonging to the reactant. But when you do the process in presence of our catalyst, you can see that this peak slowly comes down. Peak slowly comes down means this reactant is slowly vanishing from the screen, and you will see the graph here slowly going up. So this corresponds to the nitroaniline part. This corresponds to the nitrophenol part. So this is this reduction of nitrophenolate down to aminophenolate. So 4 nitrophenol and 4 nitrophenol reduction is shown here. The nitrophenol is slowly getting to the amino group, and the amino group generation is being clearly shown by the absorption. This peak slowly goes up. The nitro group reduction is indicated by the reduction in this area. Meaning, what I'm conveying is that this UV visible strategy is an ideal strategy to follow the execution of a reduction reaction. You can observe the vanishing of some specific peaks, and you can see the appearance of these specific peaks. This is a fundamental reaction. Nitro group getting reduced to amino group. And the catalytic mechanism is also given here. And we have tried to evaluate the efficiency. Efficiency is found to be crossing 100%, and that efficiency is getting repeated 4 times. Only after the very same catalyst being employed multiple times. So this is a valuable result for industry. So the efficiency gets reduced into 90 or 80% after 4 cycles. But this repeatability for 4 cycles is a good idea for industries. And then we have, that is one of the additions we have done, catalytic activity. And I have part 2 and part 3 for this work, which you can read this article. I will give the references to you. I request all of you to read these 3 articles which appeared in 2018 and 2 papers in 2020. And I think that this will give you some wonderful ideas regarding this. So with the permission of the chair, with the permission of Dr. Abdul Jalil and Professor Shantakumari, I would like to stop my lecture now here. If you have some queries, you may kindly ask me. So developing this is a beautiful area, just like beautiful flowers, a beautiful area of science. I appreciate once again the management and the department for organizing such a wonderful program. Thank you very much.
Thank you, sir, for your wonderful presentation of the history and new trends of macromolecules, which give us a new insight into the development at the opposite of polymer science. Now it is a time for the audience to ask some queries and questions. You can ask the questions either through chat box or directly unmuting the audio.
I request faculty members to have queries. Asking queries is a great habit. Particularly, I request young faculty members. Hello.
Hello.
Yes.
Jalil sir.
Yes.
ഇന്ററാക്റ്റീവ് സെഷനിൽ ആരും ഒന്നും ക്വസ്റ്റ്യൻസ് ഒന്നും ഇല്ലെങ്കിൽ നമുക്ക് പ്രൊസീഡ് ചെയ്യാം. ഒന്നുകൂടെ എന്തെങ്കിലും ക്വസ്റ്റ്യൻസ് ഉണ്ടോ എന്ന് ചോദിച്ചോളൂ.
ഹലോ. ക്വസ്റ്റ്യൻസ് ഞാൻ നേരത്തെ പറഞ്ഞാണ്, ഒന്നുകിൽ ക്വസ്റ്റ്യൻസ് ആയിട്ട് ചോദിക്കാൻ അല്ലെങ്കിൽ ചാറ്റ് ബോക്സിൽ. പക്ഷെ ആരും റിയാക്ട് ചെയ്യുന്നില്ല.
എന്നാ പിന്നെ കൺക്ലൂഡ് ചെയ്യാം സർ.
Okay, ma'am. Okay. All wishes to all the participants.
Okay, sir. Jalil sir.
I invite Gopika Madhu for the formal vote of thanks.
Hello.
Yes.
Gopika video on ചെയ്തോളൂ.
Okay, ma'am. Is it clear?
Yes, it's perfect.
Yes, clear.
Good afternoon, everyone. Honorable dignities, distinguished guests, respected teachers, and dear participants. On behalf of Majlis Arts and Science College, its entire fraternity, and the organizing committee, I feel immense pleasure to take this opportunity to propose a vote of thanks to our eminent speaker, Dr. G. Unnikrishnan sir, Professor NIT Calicut, who spared the time from his busy schedule to grace this webinar with extremely relevant address on charm of macromolecules and the new trends. Thank you, Unnikrishnan sir, for explaining and demonstrating the fundamental of macromolecule science. Unnikrishnan sir clearly explained the beauty of macromolecules when they are developed from monomers and how these macromolecules developed by nature in human bodies. He also gave an idea of dimension of macromolecules, and very interestingly, he told us about the history of polymer science even before Hermann Schollinger. Dr. Unnikrishnan sir also mentioned the revolutionary changes brought by various scientists like Ziegler and Natta. He also mentioned about the biodegradable polymers, which we are eagerly waiting. Sir, your words and presentation was really informative for us and was really great insight to the charm of macromolecules. Thank you, sir. Also, I would like to take this opportunity to place on record our hearty thanks to Shantakumari ma'am, Head Department of Chemistry, Majlis Arts and Science College, for the support and guidance she has extended to all of us. I also extend my sincere thanks to Abdul Jalil Sir, Associate Professor, Department of Chemistry, and Hari Mohan Sir, Assistant Professor of Department of Chemistry, Majlis Arts and Science College, for the enormous cooperation in the organizing of this section. And also, a big thank you to all the one who worked behind for arranging such an informative event section. We have been very fortunate enough to be backed by a team of very motivated and dedicated faculty members of Postgraduate Department of Chemistry, Majlis Arts and Science College. Last but not the least, my deep appreciation to and thanks to all the delegates who chose to be live with us and attended the webinar with great enthusiasm and made it a successful one. Once again, I thank all of you being with us in this section. Thank you very much. Thank you, sir, once again.
Thank you, Gopika. Thank you. Madam, thank you very much. Jalil sir, very thank you. Thank you very much.
Thank you.
Sir, it was a very informative and interesting talk. The beauty of macromolecules. We enjoyed it, sir.
Thank you, ma'am. Thank you, ma'am, very much. I'm extremely sorry for the inconveniences brought in due to audio breaking, because now, since we are fully online, a lot of these hardware issues are also there. I'm extremely sorry for the troubles caused.
Yes, sir. That happens sometimes. It's all right, sir.
Okay. All of have a very pleasant lunch time. Ma'am, can we sign out?
Okay, sir.
Okay.
When do we have the next session?
Okay.
Tomorrow, sir. Tomorrow,
Tomorrow.
11 o'clock.
Okay, Jalil sir, very pleasant to speak to you.
Okay. Thank you.
Thank you, sir. Thank you very much.
Signing out. Thank you.
Okay. The feedback form is there, I think.
All of you fill that out and submit. Feedback form എല്ലാം fill ചെയ്തിട്ട് submit. ടീച്ചർ പറഞ്ഞില്ലല്ലോ, നമുക്ക് അവസാനിപ്പിക്കല്ല.
ഇല്ല ഫീഡ്ബാക്ക് ഫോം ഫില്ല് ചെയ്യാൻ പറഞ്ഞാൽ മതി.
അതെ, എല്ലാവരും അത് ഫില്ല് ചെയ്യുക.
ഓക്കെ, യൂട്യൂബിലേക്ക് കൊടുത്തില്ലേ? യൂട്യൂബില് ആയിക്കോട്ടെ. ഫില്ല് ചെയ്യുന്നുണ്ട് തോന്നുന്നു. ഫീഡ്ബാക്ക് ഫോം ഒരു ഫോമാറ്റ് ഫില്ല് ചെയ്യാനും.
ഇമെയിൽ അഡ്രസ്
ശരി,